Welcome back. In this video, we're going to try to find the floor of the following function. So here we have the square root of n squared plus 3n plus 4. Note that n is a natural number. How can we find such a value for each n? Okay, remember that the floor function gives us the smallest integer that's less or equal than our value of the function that we are looking for. Okay, for instance, the floor function of 3.7, here we're looking for the smallest integer, or the integer less than or equal to this value. Which one? It's 3. So the integer that's closest to this one, but it's less than 3.7, which is 3. Here we're gonna do that in general. We're gonna find the floor function for the square root of n squared plus 3n plus 4. How can we do that? So to start, I think an idea is that we can find an approximation of n squared plus 3n plus 4. And we see what's the integer that can be close but less than the square root of this number. Okay? Note that n squared plus 3n plus 4 can be written as n plus 3 over 2 squared plus 7 over 4. All we can do here is to complete the square to find this value here. Okay. Now we note that n plus 3 over 2 and it's bigger than n plus 1. Okay. So here we can do that by noting that n plus 1 squared is less than n squared plus 3n plus 4. But this one is also less than n plus 2 squared. To do that, we have to verify all these ideas. Okay? To make sure that n squared plus 3n plus 4 is bigger than this one, all we can do is we can subtract n squared plus 3n plus 4 from n plus 1 squared, which is n squared minus 2n minus 1. So this will give us 2n plus 3, which is bigger than 0. That means this one is bigger than this. Now we're going to prove that n plus 2 squared is bigger than n squared plus 3n plus 4. To do that, we have to subtract. Okay, we have n squared plus 4n plus 4 minus n squared minus 3n minus 4. This will give us n. And n is assumed to be bigger than 0. Okay, this means that this is bigger. Okay, now we have n squared plus 3n plus 4 trapped between these squares. We can use the square root function, which conserves the order. Okay, here we can use the square root function. So here the order is not going to change, and these numbers are positive. So therefore, when we apply the square root function, we're going to have n plus 1 is less than the square root of n squared plus 3n plus 4 less than n plus 2. Okay? And we have this number trapped between two consecutive integers. Note that n plus 1 and n plus 2 are consecutive integers. And therefore, by definition of the floor function, we see that the floor now of the square root of n squared plus 3n plus 4 is equal to n plus 1. Okay? There is no other number that can be smaller than this one and bigger than n plus 1. It can't be, and it has to be an integer. It can't be, because this number is trapped between n plus 1 and n plus 2. And therefore, using the characterization of the floor function, this is the floor of our value here, our function here. Okay? We don't need to prove anything, because here we have this one and this number here, 2 consecutive integers, and we are looking for the smallest integer that's less than or equal to our value here, which is n plus 1. Okay? We can't find another integer here, okay, that's bigger than n plus 1 and less than the square root. We can't, because this number is trapped between 2 consecutive integers. There is no other integer that can be between n plus 1 and n plus 2. Okay? Note, this is very fundamental in seeing and concluding that this is the floor of our value here, of our function. For instance, we can check if this is true. So when n is 0, we should get the square root of 4, which is 2. Okay, here. So when n is 0, we have the square root of 2, which is 2, and the floor is 2. Okay. Note here that this case, we are not talking about the n's here are only in bigger than 0. Okay. Because the 0 is not in n. Okay. So here, for the case for the 0, we have the floor is 2. Okay, so the floor of our value here, n squared plus 3n plus 4, for the case when n is 0 is 2. Now we see now if this is true for our case when n is bigger than 0. Let's take n to be 2. We should expect to have the floor as 3. Okay, let's see that. If n is 2, we're going to have the square root of 4 plus 6 plus 4. And this is 14. Okay, and the square root of 14. And note that this is always less than 4. Because the next square is 4, the complete square is 4. So this is less than the square root of 16, which is 4 squared, and therefore less than 4, it's less than 4, and bigger than 3. Therefore the floor is 3, which is given by the rule that we found here. Okay, and this concludes our video. So the floor function of this square root of n squared plus 3n plus 1 is n plus 1. With the exceptional case when n is 0, it's 2.